I was also trying to call you, but I think your phone is switched off or something.
No, the phone is, I think, because I'm sitting in office, which is, network has some issues here. So inside the, my room, my chamber, okay, that is a problem. I have to go out for.
So in your your profile, you mentioned that what is this IDRIS software? Idrisi.
These are, all these software, this ArcGIS, ERDAS, and Idrisi softwares are basically used for remote sensing and GIS.
Okay. So geography.
Processing satellite images. Yeah.
Okay.
So we, in our department, we have this, work based on the Landsat and list 3 imageries for land use, land cover classification.
How many already? 30?
Around 20.
Okay. So shall we start, sir?
Yeah.
Do you need any more assist, some screen sharing, something? Sharing? Screen sharing. Exit away. Connecting audio.
I got disconnected in between. All right. Okay. So we can start now. The total, I think, 24.
Yeah,
including us. So 22
so
are there.
we can start. So rather than wasting time, let's start. Good morning to all of you. Welcome to our 6th day of the research methodology course. I'm very happy to introduce to you Mr. K. Varghese. Varghese is a system analyst, senior grade at the Center for the Study of Regional Development, CSRD, Jawaharlal Nehru University, New Delhi. He's a postgraduate in statistics. He has a number of professional diploma and certificate in software applications. He's giving teaching assistance to quantitative techniques to students of MA Geography and conducts training programs and laboratory practical on statistical software such as Stata, SPSS, R, etc. And also GIS and remote sensing using ARC GIS, ERDAS imaging, Idrisi GIS software. He has vast experience in data extraction, data management and analysis of National Sample Survey Organization, NSSO, Annual Survey of Industries, ASI, and other types of unit level data. He has conducted several lectures and workshops on data management and analysis using these kind of statistical softwares across various universities and universities, departments, and other institutes in different parts of India. He has also authored several research papers in well-reputed journals in the area of development planning. This introduction, I welcome Mr. Varghese to deliver his lecture. We will be having 2 lectures by him, one in the morning session and also in the last evening session. So I welcome Dr. Varghese. Floor is yours.
Yeah, thank you so much for your nice words. Let us begin by giving an introduction about data, and then we will switch over to the software, right? So I think I can switch on my, yeah, right. So let me just give you an introduction about data. So you all know, because most of you I have seen, The participants are, either economics or management students, and only few are in other disciplines of social science. So I hope with data, but still, for the other participants, I'll just introduce data. Data simply means informations, right? So when data, when we use it in numerical format, one must know that what are the different types of measurement levels. Okay, so that is very important. So the numerical data, the measurement level associated with numerical data, 4, and I hope, I think some are joining in between. All right. So there are 4 different measurement scale when we talk about numerical data, right? Those are, most of you know that nominal data, ordinal data, and then we have interval data and ratio scale, right? So both these, all these data, for example, the first 2, nominal and ordinal data, basically we call it as categorical data, whereas the interval and ratio, we call it as quantitative data. And basically because of its difference in statistical use, when you may, the nominal data has limitation in performing parametric statistics, right? So it's purely a non-parametric type, right? So whereas I do not know how many of you know the difference between all these, but I quickly say what is nominal data. Nominal data are data, the categorical data which is based on pure names. Okay, so for example, if you have codes given as given for sex as male and say 1 for male and female, so that you can call it as a nominal data. Or if you are coding any geographical locations, you can call it as a nominal data. For example, if you code Jammu and Kashmir as 1, Himachal Pradesh as 2. So this means for some name you are putting some numerical codes. Okay, so therefore you can call it as nominal data. Okay, so anything which, say for example, a place of residence, if you code for rural and urban, you are putting codes 1s and 2s, you can call it as nominal data. Okay. But when another type of categorical data you come across is the ordinal data. So ordinal data is also a kind of categorical data, which means that when I say categorical data, which means that you put numerical codes for certain informations, right? So those informations are having a graduated scale. So for example, if we work on this, Likert scales, for example, for ordinal scales, say for example, Likert scales like, something you call, for example, strongly agree or agree, disagree, strongly disagree. So there is an order for that, or your ranking, or your, you can say that income level, say for example, income less than 5,000, 5,000 to 10,000, 10,000 to maybe 15,000. So that has got an order, or the education level, illiterates, primary, secondary. So those things are having some order, therefore, but those are also categories. Okay, you put 0 as illiterate, or maybe 1 primary, 2 the middle, etc. So, but how does it differ? Because it differs by its order. Now 0 and 5, maybe 0, you know that, because there is a graduate order. So 0 is the least, and maybe the 5 is the best, or something like that, or the reverse. Okay, but when it comes to interval scale, you should not confuse the word interval. Okay, So interval scales are those scale which carries that property of an ordinal, which means that it is a graduated scale, but with the meaning of difference make some sense. So that means in an interval scale, difference is meaningful, but there is no absolute zero in an interval scale. Okay, so that is basically intervals. For example, you may find very few examples for interval scale, but one good example is the temperature. Temperature is an interval scale. Okay, why? Because absolute zero, because 0 degree is a temperature. Okay, so it doesn't mean any null or something like that. Okay, so it has got any true zeros in it. Okay, but the temperature difference will make some sense, whereas its ratio, wherever there is no true zero, which means that ratio will not make any sense. Okay, so interval data are those data where ratio doesn't make sense, but difference makes sense, as well as there is no true absolute zero. Okay, so when it comes to ratio scale, it carries the properties of an interval scale, plus it has got a true zero, or the meaning of zero is it in gives you a null or no, right? So it has got an absolute zero, and the ratio also the difference makes sense. I said properties of intervals, so therefore difference makes sense, and as well as the ratio also makes sense, right? So such type of quantitative, you call these interval, I said interval, and this ratio, you call it as quantitative data. So you will get a lot of examples for this type of quantitative data, that is ratio level data. So that is for almost every data we use, quantitative data, say weight, height, age, population, okay, literacy, all these are ratio scale variable, where 0 means in absolute terms no, because weight 0 means no weight, age 0 means no age, or height 0 means no height. Okay, and in such cases your ratio also makes sense. So these are the first thing when we talk about data, how you measure the data. Okay, so these are the 4 measurement levels. Those are norm, ordinal, interval, and ratio, right? And now different forms of this ratio level data. Okay, different forms. The ratio data, it can be expressed as a single variable, different variables, or it can be converted. Those variables can be converted into indicators, or those indicators can converted into indices. So these are the different forms of this ratio level data. So variables, indicators, and indices. So what is variable? The whatever raw data you are having is a variable, because it keeps on, the value keeps on changes, right? But generally, when you analyze data, you are not analyzing just variables. What you do is you may have to convert that variables, means there should be some kind of transformation of that variable, then only meaningful analysis or interpretation can be made. So what does it mean? It means that the variable needs to be converted either into indicators, or later, if required, into indices. Now, what is that? What does it mean? Say, for example, I have the variables, let us say literacy rate. I have the variable, let us say population. 2 variables are there. So with that, I should, if I want to analyze something about literacy, so I need to create an indicator called literacy rate. Okay, so what you call literacy rate is the literates divided by the population multiplied by 100. So which means that the percentage of literates. Okay, so what it means that to create an indicator is nothing but it is the ratio of two or more related variables. Okay, two or more related variables. Now, when I say related variable, that got some significance. Okay, it's not just ratio of two variables. So the variables should have some kind of relation. Okay, then only we can create indicators, right? So once indicators are created, you can perform a lot of statistical analysis. Otherwise, the raw variables you can categorize it and then find out some kind of cross tabulation frequency, etc. But the real analysis you do is after you create indicators. For example, I have sex ratio, I have literacy rate, I have work percentage of work participation rate, or etc. Okay, and now then I can do some kind of statistical analysis. And the third form which I said may be used, for example, suppose I have several developmental indicators. I have several developmental indicators. Let us say I have data on literacy rate. It's a good developmental indicator. Then sex ratio I have, work participation rate, or I have data on on electricity, percentage of electrified households, or maybe there are so many dimensions. The length of roads, Pakka roads. All these are developmental indicators. Okay, even there can be positive development indicator and negative indicators that you should distinguish. For example, let us say this negative indicators, infant mortality rate. Okay, infant mortality rate is a negative indicator, but that also can be included in creating an index for development. Say, for example, higher infant mortality means low development. Okay, low mortality rate, infant mortality means better developed in terms of other socio-economic parameters. Okay, so once you have so many indicators together, how you can create a composite index? Okay, that may be required. Suppose you are dealing with data on, district-wise or village-wise. You may have to, create some developmental index to see which district is highly developed, which is lower, so that you can make different kind of actions, right? So these are the things about the form of it. Now I will come to why we require to use statistical software, because many may feel that we have Microsoft Excel, why we should use SPSS. So that definitely will come into those who are not using statistics. They said, okay, I can handle this. No, it is not like that. When you are research scholars, so you may be dealing with large data sets. So I don't know how many of you seen this economic census. Economic census is establishment wise data, or the unit level data of annual survey of industries. So those data, which comes in, maybe in or millions of records. Okay, those data you cannot handle in Microsoft Excel. So one of the advantage of using statistical software such as SPSS is it can handle large survey data without any problem. The only limitation will be the RAM of your computer. Otherwise, if you try to open that in Excel, it will say that the maximum data Excel can accommodate is this much. Beyond that, it cannot. accommodate, right? So therefore, one should learn, statistical software, be it SPSS, Stata, R, or any one kind of statistical software will be of not only for your research, it will be for your career also. It is very important. Okay, nowadays, as you know that if you are going into industries and all, or if you are going into research institutions, okay, even in case in academic interview also, academic teaching job also, if you are an economist, or if you are in some disciplines where data is, they may definitely they will ask which type of statistical software you are using for your data analysis, and there will be some questions related to statistical analysis as well. Okay. So therefore, it's very important. But nobody is going to ask you, in Microsoft Excel what you do, because Excel is a general purpose software. Right? Whereas it is a spreadsheet where it is not based on any kind of data predefined data structure. Whereas when we talk about statistical software, it has got some kind of database principles. Okay, that I will come to later. Let's go to what does the advantage of using this SPS. Okay, so when I said it can handle large database, then it has got strong data management, data manipulation capabilities. Okay, that is not there in Microsoft Excel at all. Okay, you can transform your data in whichever way you want, you think, and that can be done using statistical software. So strong data management capabilities, right? And then SPS, when I talk especially about SPSS, its menu are very simple, easy to use. Okay, SPSS is quite easy to use when you compare it with R or Stata, but Stata is also a good program, especially for economics scholars and all, because it has got all everything together at a single location. That is a Stata, but SPSS is a module-based software that you should understand. Okay. SPSS is a module-based software, which means that for any advanced kind of analysis, you have to purchase that module. So the base module may not have all options. Okay, it will have basic options of doing your cross-tabulation, correlation, regression, etc. But if you want to do some kind of specialized analysis, like this, let us say time series analysis, or if you want to do factor analysis, you may have to include that module into this SPSS package. Okay. Otherwise, it is very easy to use, right? Another advantage of using statistical software is, it can handle many advanced statistical analysis, which you may not be able to do in other spreadsheet software. Okay, advantage of using statistical software such as SPSS. SPSS, it is a name, although it is a name given long back, when SPSS DOS was there, its full form is Statistical Package for Social Science, right? But now also, they in between, they have tried to change it, but and then again it came back to SPSS. Okay, so because it's a popular name. Okay. Anyway, so now another thing about the difference between the spreadsheet software and the statistical software, I said that it is based on the statistical software inherits inherits the properties of database software. Okay, whereas Microsoft Excel is not built on a strong database platform. Okay, which means that in Microsoft Excel, whatever you feed, you can feed, but in SPSS, you need to have a proper data structure before you create your data. Okay, so that is important. So what is, when I say it inherits the properties of database, there are so many database software you may have come across. So Microsoft Access, Fox Pro, DBase. Okay, so these are all database software. So it inherits the properties of those software, which means that whatever properties are there in a database software, so in all statistical software also that is there, because as I said, that it is basically used for analysis of large data. Therefore, definitely it should have all those properties. Now, what are the basic properties of this data structure? What are the data in between? Some are joining, so I'm admitting, right? So the data structure. When I talked about data structure, when you create a variable, it should have a proper name. Okay, so the first important thing in the data structure is name of the variable. Okay, and then comes what is the type of that data. Okay, so name associated with the information, whatever data you are putting. For example, you are putting age of people. So age can be a variable name. So, and then what is the type of that data, whether it is a string data or it is a numeric data or a date format or a logical format. Okay, so there are different data types. Okay. The most commonly used data types in statistical softwares are these two, the character as well as numeric data type. Okay, and then the important thing is, what is the, if it is a numerical data type, what should be the width of the data? How many width is required? Say, for example, suppose you are doing a general survey, and you have a variable called age. So what should be the width of that age? So if it is a general survey, ideally what should be the width? The width should be, according to me, the width should be 3. I will put 3, I will give 3 width to age, because an age can go up to 3 decimal place also. Sorry, 3 integer place also, means age can be 100 also, 101 also. Okay, but there is no sense in putting 4 width to age, because it cannot go into 4 digit. It is difficult. Okay, it will not go into 4 digits. So therefore, the ideal width can be 3. So similarly, what I'm saying that, whenever you give the width, it is not randomly you give any width. It should be meaningful. It should be meaningful. Say, for example, if you are you have the district codes in India, so the ideal width will be 2, because there are no district codes, 3-digit codes in India. The maximum districts in India, I think, is in Uttar Pradesh, so maybe around 72. So in order to store that maximum number 72, you need only 2 digits. Okay, so therefore you should use the width meaningfully, right? Then, so name is there. Then the next thing is the type, and then the width of the data. Now comes the decimal type. Decimal, how many decimals are required? So if it is a numerical data, whether it is an integer data or it's a decimal. If it is a decimal data, how many decimals you should keep in that? So that also becomes part of the data structure. Okay, and then comes labeling the data. Now, why we use labels? Okay, now labels are used because in almost all statistical softwares, label is important. Okay, now label is important because there are restrictions for naming variables. Okay, now what are the restrictions? Say, when you name a variable, you cannot write the variable name as you like. Okay, there are, a name can be, ideally it should be a maximum of 8 character width, or the recent versions of the software allow you to put 10 characters or 12 characters. But my suggestion is that whenever you define variable names, keep as much as short in naming a variable. And a variable name cannot have more than one word. Okay, so which means that if 2 words are there, you should make it to a single word by using an underscore or something. Okay, say for example, you have let us say you have a variable called sex ratio. Now, sex ratio is 2 words, sex ratio, but you cannot use such kind of name in Stata, or in SPSS. Okay, in SPSS or any software. Okay, so you may have to use SR or sex ratio joined together, or you can put an underscore in. You cannot use special character also for naming the variable. For example, you cannot use hyphen, you cannot use exclamation mark or something like that. Okay, so because of that restriction in naming the variable, you have got an option for labeling it. So labeling is for giving a descriptive name for the variable. So you have created a variable, let us say x1 or x2 or x3. So what that x1 means, you can define it. Okay, so you can give a descriptive name through this label for that particular x1 or x2 variable. Okay, then again you have value labels. Okay, so these are the important value labels. Are once you have created the variable, but what data it is going inside. So for example, I told you sex, you can code it and tools. So in SPSS, what you do, you type 1, you type 2, but you can, again, these values can be labeled. 1 is male, or 2 is female, or 1 is female, 2 is male. So that is called value labels, means putting label to the values inside. Okay, so one is the variable label, the other one is the value label. So value label is applicable where? It is applicable for basically for categorical data. Okay, so if you have a nominal or ordinal category data, so you put, I'll show you each of these through this software. So basically I have given an introduction about data, right? Now what we are going to do is let us straight away go to the software. Okay, and then first of all we can look at the interface. Okay, what is how SPSS interface is, and then we will load Excel data, and we will create try to work out some composite index. As I said, variable in indicators and index. Okay, so basically how we can create all these, and then some analysis, right? Okay, and then how recoding can be done, data transformation, and then some analysis. Okay, so right now I am just sharing my screen. Okay, wait. Can you screen my screen?
Yes, sir, it is visible.
It's visible. Okay. So I have this SPSS software. I have a version called SPSS Statistics 21. So I'm opening that software. Okay. So this is the direct interface. You know, when you open SPSS, what you are getting is this screen. Okay, with a dialog box here, so you can cancel this. You don't want this. So this is basically the screen. Now, you know, there's a big difference between a Stata and SPSS screen. Stata, you know, the data screen is hidden in Stata, whereas when you open SPSS, what you are getting is an arrangement of rows and columns. Okay, so you can see here, and just like Microsoft Excel, you can see rows and columns here. Okay. Now, if you go to the lower left, this bar, so you can see there are two options: data view and variable view. Okay. So what is data view? Data view is the view in which you see your data, and variable view is the one where you see the data structure. Okay. So basically, variable view means viewing the data structure. Okay. What is the name? What is the type? What is the width of the data? How many decimals are required? Labels, value, etc. Okay. Then you can define missing, etc. Alignment. You can do what are the measurement scales. Measurement scales, ordinal, nominal, etc. is there, which you don't have to do up to here. You define. And basically the next, all those, now even in some cases missing also can be defined, and all other by default it will take on its own. Okay. So variable view, data view, where you see the data. Okay. Now if I type some data here, I can type the data where? In the data view. So if I start typing some data, let us say some name, let us say Sharma, or I say okay, something like this. If I start typing the data, the moment I start typing the data, now you look at this, and here I started typing something here. Suppose if this is age. Okay, so by default, now two things, I have typed some character without defining the data structure. Look at this, without defining the data structure. So what happens? SPSS automatically, the moment you start typing in a column, will assign a variable name. So it starts with var 00001, then var 00002, and if you start feeding data in the next one, it will show 3, 4, etc. In all these, if you look at, if you count this number of characters, they also kept, even if you can, I said you can name a variable with more than 8 characters. Still, they have kept the number of characters here as 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Ideally, so therefore, but nowadays, because of the newer version of the software, they also update it with more number of characters for naming the variable. But I would not recommend it, because if you are writing programs, syntaxes, writing short name always will be easier for you. Okay, otherwise you'll have to remember the spelling, or you may have to type more. So if you define small short names, it is easy to write in the syntax and all. Okay, so this is how you create it. But once it is created, you just go to the variable view and see what happened. Automatically, it created a structure. So what is variable one? Because I typed some alphabets, it assumed that it is string, and then it gave a width of 6 is the maximum characters I typed inside, I think. Okay, so that is the reason why it gave 6, and decimals is it's not applicable also here. So you cannot put it will not, you cannot change it, because it is a string variable. So decimal is not applicable for, and we don't have a label here. Now with this, for this variable, you can create a label because that I have typed name of person. So this is a label attached to this particular name. Okay, because this thing you cannot write in the name because there are restrictions. Okay, and suppose this is age, I can write age. Okay, now for age, I don't need the decimal place too. I can put it like this. So you go back to data. So now that 23.00 becomes 23. Okay, so if you create proper data structure, the data also will look like how you want it. Okay, so now you see that if I point my mouse here, it shows name of person. Okay, so even if your name is whatever may be x1, x2, y1, y2, if you label it properly, then you can see what exactly the content of that. Okay, so this is age. So whenever you do any kind of analysis, rather than instead of variable names, the result will come in the label. So there will not be any kind of confusion at all. Okay, so this is how you can. Now it is not that you type something and create. You can create a. Suppose I want to create some variable called x1, x2, x3. Okay, so suppose it's a numeric variable, and suppose I'm suppose feeding the job of that person. Okay, so I don't need for job. Suppose I have coded, it's a nominal variable, so I put maybe maximum. Suppose only 5 type of jobs are there. Assume then I need only 1 digit. Suppose there are around 10-15 types of jobs, so you can put a code 2. Okay, and here we have written job, and similarly you can create other education level. Suppose education. Okay, education also, it's a categorical variable, so you can put, let us say 1 digit. That's fine. Okay, now education seems, suppose if you want to take this education to maybe up, so you just drag it here and your education came in the third position and job afterwards. That way, if you change it here, what I did is I just dragged it. See, if I press it and then bring it, you can bring it anywhere. Okay, so if you does that, view also your education will come first and the job second. Okay, so this way you can manipulate the variable properties, right? All right, so what we do is let us just work with the real data. Okay, and then what all things we will do is we will learn how to create the indicators first, and then how to recode the variable, and we will create some basic tables, maybe frequency, then we will do cross tabulation, and then how to create summary tables. Okay, and then we will create a composite index using a standardization method. In case if you want, we can use PCA also for creating composite index. That also we can see. Okay, and then some correlation and regression. Okay, so let us just open a data, external data. Okay, so some data for you. This I have a data of census data, as well as I have data of annual survey of industries. Okay, ASI data. But you can see that the ASI data you can't use as it is, because ASI data is very complex data. Okay, one must know that I opened this data. It looked like this. This data is of any you can't use it. At the moment you cannot make use of this data. Okay, I think somebody is joining in between. Okay, So what we do is we will first look at how an Excel data can be brought into SPSS. Okay. So I'll show you what I had the data. I had this data. This is census data of 2011, which is the total. Okay, total number of households. See, I have three data: total, rural, urban. Okay, so the total data means rural and urban added. So what is this data? This data gives you the primary census abstract, which is about the total number of households, the population, the literacy level, SC population, ST population, workers, broad workers category, like, you see, if you go towards the right, you'll get the, you can see the main working population. See, there are two kinds of workers that add up to this total workers, that is main workers and marginal workers. Okay, or what we call in NSSO and all the principal and subsidiary activities or work. Okay, so here we have the main and marginal workers. Now again, main workers, agriculture laborers and household industrial workers, and we have other workers. Now, why these three column for cultivators? For each one, it is given total, that is persons, then male, then female. Okay, so three column for one, type of variable. So cultivators, total, cultivators male, cultivators. So likewise, everyone here, if you look at the literacy also, it's literacy person, literacy male, literacy female, likewise. Okay. And along with that, the number of households are also there. Okay. So I think you got an idea about what data we have. Now, what I did first is, this is how I get the data from Census of India website. So if I go to the RGI, Research Journal of India website, I can download this free of course. You can download any data, not only PCA, any type of series, B series, that is economic tables, C series, sociocultural tables, or D series data, migration tables. So many data are there. So you can go and download it and then further do your analysis, right? Now, I'm closing this, but I have made some changes to data that I see. I have removed, this is number of households, total. So I don't want the variable, because I said that there are restrictions placed in naming the variable in SPSS. So I have changed it into short names. So I'll close this and I'll open that file. That is the difference between these two files. Okay. So this is the district PCA, okay, with that short names. The variables are same, but I have used NO_HS, number of households, total population, total male population, total female population. Now these are 0 to 6 child population. Person, male, female. Then SC population, person, male, female. Likewise, I used single words as the variable names. So that is very important. Right? So now, I'll close this. Now, how we can open this file? Okay, close this. Okay. I will not save this. I will first thing. Now, before just let us just introduce you about the other interfaces, other indirect interfaces available in this. So other than this data, you have, if you look at this new or open, you can see data is there, syntax is there, output is there, script is there. Okay, so out of which data means SPSS data. Okay, now what is the default extension of SPSS data? That is .sav is the default extension of statistic, this SPSS data. So then the next one is syntax. Syntax is writing commands how you can write certain commands to execute something. Okay, so syntax are SPSS understandable commands. That is not a syntax here syntax. Okay, any syntax means the one it is not a general language. Okay, syntaxes are not general language, but it is application specific commands. Okay, so it is basically a command which only SPSS can understand. Wherever, if you use Stata syntax also, Stata can only understand it. Okay. Output, now, what is the extension of syntax? That is .sps. Okay. So basically, you will have an extension here for data. You have a .dav, .sav. For it will not the other one for syntax you have .sps. Okay, and then you have output. Output also is different interface. Okay, which means that wherever you type the data, you are not seeing any result, or you cannot write any syntax in your data script. Okay, so your data will have a different interface. Syntax is a different interface, output is a different interface. Okay, so each interface has its own extension. So .sav and this .sps and this is .spv. Okay, .spv. So an output has, result file has .spv extension. Then you have script. So script, WWB, I think is the extension. Now scripts, what are scripts? Scripts are in fact not just statistical language. It is a general language. Say for example, SPSS support 3 script as of now. The latest version of SPSS support 3 different scripts, two different scripts. One is Visual Basic. Visual Basic is a general program language, and then Python scripts. So, this version, I think this is 21st version. This has only one language, that is Visual Basic. But if you are using 24, or 25th, the latest version, it is having the Python also included, which means that for executing something or formatting something, you can write some programs. If you are good in programs, you can create programs. Now there is no the macro, because this WWD is the extension of script, but the script will not work because some module which is required for writing the script is not available with this, because this is not a licensed software, right? So okay, so even then that screen game, but that the script will not run because that macro module is not there. So this is language. Okay, www. So this is the format of sub, main, end, sub. All these are the format of Visual Basic. Okay, so I'm not going into this. So we are not going to use that. Now, generally we use data, syntax, and output. Okay, scripts are meant for very good, programmers in, in conversion of the result into some special formats, or some highlighting of the data or something. Okay, so that is, even the SPSS has also have certain kinds of script built in. Okay, if you go to the, I'll show you one just quickly. What is script? Open script. Go to I think maybe directory C drive. So where is the program files? IBM, SPSS, statistics 21. So if you go to the scripts, there's so many scripts available. Traffic light. Traffic light is not the traffic light. Traffic light, suppose you want to highlight something, you can use the traffic light. So I want to highlight in a result, if I want to highlight all values more than 0.5. So it automatically does if you use the script. Okay. So the scripts are, now if you PPT export, if your result if you want to export directly to PPT, you can use this script. But this script now, it will not run because we don't have that module with me. So therefore, it will. Otherwise, the scripts are very good in formatting your results and all. Right. So I'm now going to that particular data we have seen in Microsoft Excel. How? So go to File, click on Open, and then Data. If you look at this data, we have extensions like this SPSS statistics. Now this is the default one, .sav SPSS stat. Another one, SPSS statistics compressed, that is .zsav. Suppose you are getting some data .zsav, you should understand that it is a compressed statistical format. What is compressed statistics? So large data sets. If some computer is if I want to share my data, I have a large data sets, okay, but I want to share it with a person having a computer having very low memory, okay, it cannot read large data sets. What I will do is I will save my file as .zsav so that he also can analyze the data. So using a .zsav file also you can analyze the data. So it is a compressed data, which means that the data will be the size of the data will be reduced considerably. Okay. Now there are other options. We see this these days nobody uses SPSS because PC SPSS means the SPSS at the time of that before this Windows comes, there was a DOS version of SPSS, so in which the data extension of SPSS was .sys. So if you have a data which is typed in late 1980s or beginning of 90s in .sys, that also can be opened. It is made compatible with the latest graphical user interface. Okay, so .sys. Now sysstat is a another statistical software. So if you have a sysstat software, if you have a file of .syd, so you can easily open. Then portable format. This portable is a SPSS created. You can say ASCII file. So it's a generic test data .portable POR or Microsoft Excel file Lotus 123 WKS or WK1. Okay, Lotus is also a kind of spreadsheet software. Okay, and then SYLK. SYLK is a file, you can say file interchange format of Microsoft .slk. Okay, so I don't know whether you will come across this kind of data. DBase is, yes, you can come across how when you use 1991 census data. If you look at the Census of India website, in some of the 1991 census data is given in DBF format only. Okay, so if your data is a database format, you just have to click here and then open that data. Okay, then SAS format. SAS is statistical analysis system. It's a very high-end business analysis software. SAS. Then Stata. So it is compatible with Stata also. If you have a Stata file also, you can bring it here. And then the general text format, .txt or .dat or .csv format. Okay, so these are the files which you can bring in to SPSS directly. Okay, so right now our file is Microsoft Excel. Right now, where is the file? That location you have to say. So location is, go to the desktop. I have created a, I think, ISID SPSS. So my file is here. So I'm going to open this. Click open. So now in this one, opening Excel data source, it says read variable name from the first row of data. Now it is asking whether it should read the variable name from the first row of the data. So it is by default, it assumes that we provide some variable name also. So that is true. In our case, we have created the variable names. Okay, so that is true. And here you don't have to do any changes, and it automatically look at the in this file. It will look at the first sheet and see how many data are there. Automatically that comes. Suppose you don't want this much data. You want only part of that data to brought. Then you have to mention what is the range of the data. Okay, so we are going to bring in all data. So you click OK. So you can see a new screen has opened. Now the earlier one, it is there. Okay, if you want, you can close it. So it has save changes. No, I don't want to change. Save changes. So you just close it. So now only only one instance of data is there. Okay. Now you see, as I said, that whenever you output is a different interface. So whenever you do something here, so the copy of that will. So what action I performed is I opened an Excel file. So the corresponding syntax, it will give a copy here. Okay, you don't need it because SPSS syntax are slightly complicated than Strata. So you are not going to use this syntax for opening the data. It's easier through menu. You go to file, open, etc. Okay. Even other thing also, in SPSS menu is much better. Okay. I'll show how you can write syntax and all. That I can show, but still, using menu is easier in SPSS. Now see, all data, the variable name has given. Now, if you look at in the data, everywhere it put points. It assumed 1 decimal places. Okay, so it has put 0.0, which means that here there may be 1 decimal place. So I don't want this decimal place to see. So I don't want to just change each one separately. So what I do is I just copy it and paste it here. That's 0. So all became 0. So which means that I go to that dot 0 has got. So I have got the data here. Now the variable name here, but I don't have the label. Either the label you can type here. How, say this is number of households. Number of households. Number of households, total population, etc. etc. You can go and type here, so that as I said, that it will show all those labels here. Okay. Another way of typing the label is through the syntax. Also, you can do. Suppose, see, I'll just quickly show. Suppose I want these variables up to, let us say, here. Okay, how I can quickly do this? I'll go to Excel file. I have. Where is that Excel file? Yeah. So these are the labels. Assume that I have continuously, okay, let us say up to here. Okay, just type this. What is this? Control C. So I'm just putting this as page special and I'm transposing it. So I got this one. Now, you may find it difficult, but for me it is very quick because I'm taking some time to teach you. Otherwise, I could have done in a very quick manner. See, what I do is I copy it till here. Again, I put it here. Page special transfer. So what I'm saying, these are the variable names, these are the descriptive names. Okay. So what I do is create a concatenate statement. Okay, now this concatenate statement, just see what I'm doing. Okay, concatenate. I'll say that this, then I'll put a space, then within quote. For getting a single quote, I put 4 quotes. That is how SPSS, sorry, this Excel takes. Okay. So you see 4 quotes. Okay, and then close. So I will see what I have got is number of household, then a space within quote I put number of households. So if I drag it, I get like this. So let us see whether I can write a small syntax to get my labels there. So for labeling, what I should use? Variable labels. Variable labels is already there. Okay, variable labels. I just copied it here and I put a dot. Okay. So it seems difficult for you, but it is very easy. Okay. So what I did, variable labels. Now the variable name followed by the descriptive name, and at the end, whenever I have to stop that command, I have to put a full stop. So I have put a full stop. That is called the command terminator. Okay. So when you do this, you run this. So what you are getting is all those came here. Okay. So this is how you can run a sentence. So a program can be run. So you just created a syntax. You clicked on this run button is to execute this. Now, because you have not made any changes in the data, you are not writing here execute. Otherwise, suppose a transformation, numerical transformation is done, then you need to write even execute also. But here it is not required. This execute, even if you do an execute, say any problem, any error, okay, it done, but you don't require it because you have not made any changes to the data. You have just put the labels on it. Okay. So this is how you can put labels without typing it. Otherwise, you have to manually type it. So what I did, I know the variable names. I know the descriptive name of that. So I just pasted it here. And then I used a command to SPSS takes for labeling the variable, it takes the name first, followed by a space, and then within quote the descriptive name. This is how. So to get this easily, what I did is I used concatenate command. So concatenate. Now B2, why I read B2 is because these are variable. This is a variable because it keeps on changes. It's a variable. So wherever you use variables, you use the reference cell B2. Then you need a space. So that space should be put it in within quote space. So one space you put here. And then you need one. This is very tricky. You may think logically, you may think why I should put 4. So this is how the SPSS, the Excel takes. Okay. If you put only 3, it will not take. Let us see. Logically, you may think that within quote I should put 1 quote, but that may not work. Okay, so this is if you do like it didn't work. Okay, so in order to get a single quote, you should put 4 quotes at the beginning and the end, and in between you put that C2. Again, this is a variable because it keeps on change. The description keeps on changes. Okay, so this way you get it. Once you see the difficulty of writing this is only once. Once you return, you are just dragging it. So now thousands of entry, you just have to double click. Okay, So it automatically will come. Just like you just click here and you double click this. So it appears. And then you copy that, paste it in your syntax and run it. You will get all the labels here. Hope you understood. Now, all right. So we have some labels here now. Okay. Now, let us straight away start creating some indicators. These are your variables: number of household, total population. Okay, the data in raw format. These variables. Now, I'm going to create some indicators out of this from this. So let us create. Okay, so let us do one exercise now. That you know, I told in the beginning to have with the forms of different forms of you know, variable. Then I said indicator, and then I said index. Let us create indicators, and then we will create. Then we will create. Just a minute. Then we will create index. Okay. Okay. So let us create some developmental indicator now. So we can create, let us say, child sex ratio or sex ratio. Now, how to create sex ratio? You know that the sex ratio formula is female population divided by male population multiplied by 1000. Okay. So what I do is I go to transform. So in order to create a new variable, in Stata we use generate, but here we use compute. So compute is a command used in SPSS for creating a new variable. So compute variable, what we are going to compute is sex ratio. So like this. I cannot write sex space ratio, remember. Okay, it will not, it will say that you have entered an illegal character. See, I'll just create this mistake and then I'll show you what mistake we did. So that is this is, I think, female population is this. Yes, total female population. If you don't want to see the now, with this, let me just see whether, yeah, if you can do like this, you can see female. Okay. Otherwise, what you can remove this label for the time being temporarily. Display variable names. So it will only display the variable names. Okay. That can also be display variable name with label. So that options are there. Okay. So total female population divided. Now you have got a screen that is with the arithmetical operators, logical operators, and relational operators. What are the arithmetical operators? Plus, minus, into, that is star, and division. And this is, I think it's a logical operator. This is also this exponent. So it can be termed in the arithmetical operator. So it's exponent. Now this one not, this is and, this is or, these are logical operators. This is for bracket, and these are relational operators. Okay, this is equal, this is not equal, this is less than or equal to, greater than or equal to, less than, greater than, and then the numbers from 0 to 9 and then a dot. So these are, so without, what I'm saying, without typing, you can manage, or you can create the indicator. Now you selected this. Now what you do, you put a forward slash, that means divided by, you click on the male population. Okay, male population, and then the whole of this thing can be put within bracket, and then you multiply it with 1000. So I haven't, in fact, used my keyboard. I just used my mouse and clicked. Okay, so that easy is in SPSS how you can create indicators. Okay, So we have created sex. Now, will it work? Oh, so see, because variable name contains an illegal character. So that is what I said, that you cannot define such kind of variable having more than one word. So either you remove it or you can put an underscore sex ratio like this. Okay. So once you do that, click OK. So you can see at the end of this, you can see that variable sex ratios. So it is created. So how, what is this? 835 female per 1,000 male in Kupwara district of Jammu and Kashmir. Okay, so that, but that is the meaning of that. Okay, so 1011. This must be some district in Himachal Pradesh. I think 1011. Yeah, Kangra district of Himachal Pradesh is having a female, more female population than the male population, right? So per every male, there are 1011 female. Okay. So this is, one indicator we created, and then you can create other indicators, compute variable. Now let us say, now if already, whenever you open this, the already executed formula will be there. Okay, so you can use this reset button. There's a reset option, or you can type over it. Okay, either you type over it, or you can reset, means it will go disappear, or you can remove manually also. Just delete it from here and then type the. So let us create so sex ratio. Let us assume that sex ratio is a in Indian scenario, what we consider sex ratio as a development indicator, because female proportion is more, means it's a highly developed area or something like that. Okay, so we associate it with development. So let us, sex ratio is a good indicator. Okay, and then let us create another one, literacy rate. Literacy rate is there. So LIT. In case anybody is having any doubt in between, you can ask. Okay, you can ask. Yeah.
We have 10 more minutes. We have another session at 11:50.
So okay, you have a session also, huh?
A session at 11:50. So the time for this session is up to 11. Your next session will be at 3 o'clock. So
no. So I should stop at 11, or I have some 5-10 minutes. No, 11 I have to stop. Huh?
You can take your time up to 11.
11. Okay. So I quickly create some indicators, and we will create this index and then stop, and then we will come back to other thing. Okay. So literacy rate. I think within next 6 or 7 minutes, I will finish it, and then 2-3 minutes I will give for questions. Okay, if you have any questions. Okay, so literacy rate, quickly I am generating, that is literates divided by the population of 7+ age group population. That is how the census defined the literacy rate. Literacy out of population which is more than 7 years age. So total population, I don't have 7+ population. What I do is I say total population minus 0 to 6 age group population, and the whole thing I put it in bracket and then multiplied by 100. Okay, and then you click OK. So you have got another indicator here, right? Now I will create. Now literacy rate is also a good development indicator. So as the literacy increases, the area is supposed to be better developed. So that also a good indicator. Now we can, I have one variable, that is main workers, main other workers. Now what is this main other workers? Main other workers is the workers which is other than agriculture as well as household workers. Okay, so basically the major portion of this is the secondary and tertiary sector. It's because household industrial worker is included in secondary sector, but if you remove it, so you can say that it's full tertiary plus part of secondary. So let us say this also considered as a development indicator. So transform, compute. So you can say that percentage of other workers. So you can join this like PER underscore OTH other and underscore work, and then you can remove it, or you can reset as I said earlier. So let us say what is the proportion of main other workers out of the total main workers. So total main worker is here, and you can put a so we have created three indicators here. So these are indicators. Okay, these indicators can be recorded, to get a distribution of the data, or people are joining. Okay, then it can be used for correlations, or you can find various other statistical tests also, right? So right now, since I was talking about the data forms, now we have three indicators. Now I'm going to create an index of this. So, okay, so assuming that all these are equally important, what I do is I will change that. I will change. I will remove the scales from this. Then only I can add the data. Okay. Or what I'm saying is I'm making this data scale free. Okay, because this is calculated per 1,000, or this is 100, or when we use other data. It's important because when we use a data, which is suppose, let us say number of roads in kilometers. So its unit is different. So in that case, you need to make all the variables scale free so that you can add it up to get a composite index. So how you can standardize this? Standardizing means you are making this data between with a mean of 0 and standard deviation of 1. So how quickly you can create that? You go to analyze, you go to you go to descriptive. Now don't do you can do this both descriptive. So I'm just finding out a descriptive of this. Means descriptive gives you summary tables, which means that how many observations are there, what is the mean, what is the standard deviation, etc., along with save standardized value as variables. Okay, so you click OK. So save standardized values means it will create Z values. So look at Z of sex ratio, Z of literacy rate, Z percentage of other, which means that what does it mean? It means that each observation minus its mean divided by standard deviation. How that is how you standardize the variable. It's now if you find out a mean of this, definitely the mean will be 0 and the variance will be 1. So once it is scale free, now you can add it up to see which is the best district in India. Suppose I want to add these variables together. Now, the earlier thing you cannot add like this. When it's an indicator level, you cannot add it because different variable has different scales. Okay, once you made it scale free, okay, add it up. So what you do is you go to transform, you compute, you reset it, and then you say that the composite index of this or developmental indicators is this sum function. I use sum function of this, comma, this next one, comma, this. Or you can do, or see, this is sum is a function. Or you can do this plus, then sum. You don't need sum. Okay, you use this plus this plus this. Okay, so that also is possible. So you have now created a composite index. Now this composite index, higher value indicates better districts, lower indicates, see this one, 4.42. It's got a very good higher value, which means that in all these three dimensions, this particular district, Hamirpur in Himachal Pradesh, is a much better developed area, you know, in that sense. Now, if you go down, so if you, based on this, you can even sort this data also, data sort. Okay, sort cases, you can see based on this, your descending order. So you keep, see, even 9 composite index also is there. So looking at this, you can see Puducherry, Mahi is the best. Then Kannur, Thrissur, all of the Kerala districts came up. Then Udupi, Kanyakumari. So these are the index we created based on these 3 variables. So this is just an example. If you have several variables, you can use it and then create developmental indicators. So here I stop, and then from here onwards, we will do something else in the next session. Okay, and then if you have any question, we have 2 minutes more. So if you have any question, you quickly ask.
Good morning, sir.
Yeah. Good morning.
So, would you explain regarding to how to get and raw table, raw data?
Yeah. I will tell you in the coming next session, because now restriction is there. 11 o'clock I have to. From 3 o'clock, I will tell you that all correlation.
Thank you.
What else? Anything? In this one, you have any doubt? You ask. So these are poorer districts in terms of, you see, Uttar Pradesh, some districts are there, Madhya Pradesh, Bihar. Okay. So,
So there is a suggestion. Can you share the data for practice in the chat?
yes, I can. I will share. Okay, right now I will share, so you can practice and.
You can email that to me so that.
Should I do it now, or should I do after the next session also? I can do even now or after the next session, so that we can practice.
Email it.
So let us, because we will do some more thing, na? So then I will save it and then I will send after that session. So it's 3 to 4:30. So 4:30 again. After 4:30 I can send it. Is that okay? Anything else?
I think participant might be having questions to ask, but because of the time constraint, I think we can.
Okay, so you can ask the question, afterwards also when I.
Yeah, because three onwards we have so much time, so that time we can have a comprehensive.
Okay, so I'm just saving this data, census 2011, so that we can continue from here. Okay? Census 2011, save. So the data is saved now. Okay. All right. So I'm closing the session now. Exactly, we are at 11.
Yeah. Thank you, sir, for this introduction to the data management. We'll be having a detailed discussion in the afternoon session. There is only one session in the afternoon. So it's on time, so there is no issue for time. There is no time constraint on that. People interested can have a detailed discussion also. So let us stop for now.
All right. Okay. Thank you. So I can leave now.
But sir,
I can leave now. No?
You can leave.
Okay.
Thank you very much. Okay, participants. So do you want me to share the data set? What you suggest for practice while doing what you suggest? Or is it okay?
Yes, sir.
Yes, sir. Please share. It would be.
Okay, you want me to share? Okay, I will contact him and let him share.
So that we can also open it and.
How many of you are having SPSS now?
I have R, not SPS actually.
Okay. So let us stop.
I'm using SP.
Who is that? So let us stop now. For next session is at 11:15. So okay, then see you all soon. We'll sign out now. From now, okay.
Yes,
Bye.
thank you.